Designing. The lateral section of the building is different, for different sets of stories. Not only this, the live loads are also different, for each of these sets of floors. For stories 1 to 8, the live load is 5 kN per meter square. For stories 9 to 14, it is 4.5 kN per meter square. The live load decreases to 4 kN per meter square, for stories 15 to 19, and is 3.5 kN per meter square, for the last set of stories that is 20 to 23. These properties can be applied, by the concept of similar stories, which you will learn in this module. Also, 3 sections of beams and columns are listed, each of which are having M40 concrete, and HYSD 500 and mild 250 rebar, for longitudinal and tie bars respectively. You will be using the Auto Select option for the beams and columns, which means you will list all the 3 sections, and ask the software to select the best section for you. The slabs are of 150 mm, and having M40 concrete grade. You will use auto draw claddings, that is walls without self-weight, so a cladding load of 0.2 kN per meter, is to be applied. For the wind load, you will consider the parameters for a building, to be constructed in Bangalore City. Open the Etab software. Select New Model from the File menu, and select the usual options as displayed. Then click on OK. In the Uniform Grid Spacing option, set the number of grid lines as 4, in both X and Y directions, and set the spacing values to 6 meters each, in X and Y direction. Then in the Simple Story Date option, set the number of stories to 23, and both the typical and bottom story height to 3 meters. Now, you need to define the set of similar stories, so select Custom Story Data, and click on Edit Story Data. You can see that, Story 23 is set as a master story, and all the other stories are set as, similar to Story 23. So this means all the stories are similar now, and you will create different master stories, to divide the stories into smaller sets of similar stories. Story 1 to Story 8 are similar, so go to any one of those stories, and in the Master Story option, select Yes. Then set the other stories, as similar to the new master story. Please note, here Story 8 is set as master story, but you can select any other story, from 1 to 8 for that, and set the remaining stories, as similar to that master story. Now, for the next set of similar stories, that is Story 9 to 14, select Story 14 as master story, and set stories 9 to 13 as similar to Story 14. Again, for the third set of similar stories 15 to 19, select Story 19 as a master story, and stories 15 to 18 as similar to Story 19. The remaining stories from 20 to 22 are already similar to Story 23, so the fourth set is defined by default. So now, you have created 4 different sets of similar stories, and you can assign properties to only one set, using the Similar Stories option, while modeling. Click on OK to exit. Select the Grid Only option, and click on OK. The 3D grid has been created for you, to draw elements on it. Go to Define, and select Material Properties. Click on Add New Materials. Select Region as India. Material Type as Concrete. Standard as Indian. And the concrete grade as M40. Click on OK. Then click on OK again. Again click on Add New Material. And this time change the material type to rebar. And grade as HYSD 500. Click on OK. Then click on OK again. Similarly, add one more rebar material, of grade mild 250. The 3 required materials, M40, HYSD 500, and mild 250 has been defined. Click on OK, to exit the Define Materials dialog box. In the next part, you will learn to define the structural elements of the building. Thanks for watching. Welcome to the second part of the video on the final project in analysis and design of a tall building. You have already defined the material properties of the elements. Now you will define the frame and slab sections with these materials. In the Define menu, select Frame Sections from the Section Properties option. Click on Add New Property, and select the Concrete Rectangular option. Enter a name for the column section of 500 mm by 500 mm. Change the material to M40 and the depth and width of the section to 500 mm each. For the reinforcement properties, select Modify/Show Rebar. Set the design type to column, and change the longitudinal bar material to HYSD 500, and the tie bar material to MILD 250. Keep the default values for the other properties, and click on OK. Click on OK, and the column of 500 by 500 mm section has been defined. Now, you will need to define two more columns, which are having similar properties as this, with the only difference being the section dimensions. So, instead of adding new property each time, click on the just defined column, and select Add Copy of Property. Here change the section name, and change the section dimensions, to 550 mm in both depth and width. If you select the Modify/Show Rebar option, you will see that the settings of the previously defined column are already there, so you need not define them again. Click on OK. Then click on OK again, and the new column section of 550 by 550 mm dimension has been defined. Similarly, select the column one more time, and click on Add Copy of Property, to add another column of 600 by 600 mm dimension as shown. Now that the three column sections are defined, you will need to define a fourth property, which is having a combination of all the three defined column sections. Click on Add New Property. Here, under the Special option, you will find an option, Auto Select List. Click on the Auto Select Section List option. Give a property name for the Auto Select list. Then change the design type to Concrete. Then select the three defined column sections, and click on Add. The three column sections have been added to the Auto Select list. Then click on OK. Now, while drawing the columns, you will not be using the individual sections, but the Auto Select List property, and the software will automatically select the best section from the list, depending on the internal forces. Add the three beam sections similarly. Click on Add New Property, select the Concrete Rectangular Section option. Enter a name for the beam section, of 500 mm by 300 mm. Change the material to M40, and the depth and width of the section to 500 and 300 mm respectively. For the reinforcement properties, select Modify/Show Rebar. Change the design type to beam, select the longitudinal rebar material to HYSD 500, and tie bar material to MIL 250. Set the clear cover, for both top and bottom bars as 25 mm, and then click on OK. The rebar properties of the beam section has been changed. Click on OK, and the beam section of 500 by 300 mm has been defined. Now you add two more beam sections, which are having the same properties, except the dimensions. So, click on the Just Defined Beam section, select Add Copy of Property. Change the property name for the 550 by 350 mm beam section, and set the depth and width values to 550 and 350 respectively. Click on OK. And the beam of 550 by 350 mm section has been defined. Similarly, select the beam one more time, and click on Add Copy of Property, to add another beam of 600 by 400 mm dimension, as shown. Now that the three beam sections are defined, you will add the Auto Select List property for the beams, just like you had done for columns. Click on Add New Property, and select the Auto Select Section List option. Give a property name for the Auto Select List. Then change the design type to concrete. Then select the three defined beam sections, and click on Add. The three beam sections have been added to the Auto Select list. Then click on OK. You now have two properties, one beam Auto Select, and one column Auto Select, each of which are having an Auto Select list of three beam and column sections respectively. As explained, the software will decide the most suitable section for each and every element, depending on internal forces and stresses, and all you need to do is draw the frames, using the Auto Select properties. Click on OK, to exit the Frame Sections dialog box. To define the slab section, select Slab Sections, from the Define menu. Select Add New Property. Enter a name for the slab property, and change the slab material to M40, and thickness to 150 mm. Click on OK, and the slab has been defined. Click on OK to exit. In the next part, you will learn to draw these defined element sections. Thanks for watching. Welcome to the third part of the video on the final project in analysis and design of a tall building. You have defined all the required properties and sections, and now you can proceed with the drawing of the elements. In the plan view, go to Story 1, by using the arrow keys. Select Quick Draw Columns, from the Draw menu. Alternatively, you can select the Quick Draw Columns icon, from the shortcut bar. Now that you are well versed with the draw icons, most of the draw functions are selected from the shortcuts in this video. After selecting the Quick Draw Column option, change the column property to the Column Auto Select List property. Before drawing the elements, select the Similar Stories option, from the bottom right corner. Then select the whole grid area, to place the columns, at the grid intersections. As you had selected Similar Stories, you can see that, the columns have been drawn in all the stories, which have been defined as similar to the current story, that is Story 1. Now, select the Quick Draw Beams option, from the Draw menu, or the shortcuts bar. Change the property, to the Auto Select List for Beam, and then select the whole area, to draw beams over the grid lines. The beams have been drawn in the set of Similar Stories, from Story 1 to 8. Again select the Quick Draw Slabs option, which you can do from the Draw menu, or the shortcut bar. Change the property, to the defined property of slab, and select the area to draw slabs on it. The beams, columns, and slabs have been drawn, in the first set of Similar Stories. Using the arrow keys, go to any one of the stories, from 9 to 14. Make sure Similar Stories is selected, and click on Quick Draw Columns. See that the Auto Select List property for column is selected, and draw the columns over the desired area, as displayed. Similarly, select Quick Draw Beams. Check that the correct property is selected, and carefully select the desired area as shown. Make sure that the correct area is selected, for each set of Similar Stories, which has been accordingly illustrated here. After the beams are done, select Quick Draw Slabs, and draw the slabs of the desired property, over the area. The beams, columns, and slabs have been drawn in the second set of Similar Stories, that is Story 9 to 14. Now, go to any of the stories from 15 to 19. Select Similar Stories, and click on the Quick Draw Columns options. Select the Column Auto Select property, and select the desired area, as illustrated. The columns have been drawn, in the desired building section. Again, select Quick Draw Beams, check the correct beam property, and select the same area to draw the beams. Select the Quick Draw Slabs options, and repeat the process of selecting the particular area. Press Escape, to exit the draw mode after the slabs are done. Now go to Story 20, to draw in the last set of Similar Stories. Select Quick Draw Columns, and set the Auto Select property for column. You can draw using the Similar Stories option, as before, but here an alternative option has also been illustrated. First select the One Story option, and then draw the columns on the required area, as displayed. Similarly, draw the beams and the slabs, using the respective Quick Draw options. Then press Escape, to exit the draw mode. Now, with the One Story option selected, select the whole area, so that the beams, columns, and slabs of only the Story 20, are selected. Then go to the Edit menu, and click on Replicate. Select the Story tab in the Replicate box. The elements are already drawn in Story 20, and you need to replicate the same elements, to the rest of the Similar Stories 21 to 23. So, select Stories 21, 22 and 23 together, and click on Apply. You can see that, the selected elements have been drawn in the remaining stories. This alternate technique may be used to draw elements on a particular set of stories, without using Similar Stories options. Click on OK, to exit. So the beams, columns, and slabs have been drawn in all the floors of the building. In the next part, you will learn to apply the dead and live loads to the building slabs and claddings. Welcome to the fourth part of the video on the final project in analysis and design of a tall building. You have completed the drawing of the building model. Now you will learn to apply the loads on the slabs and claddings. Since the dead load is same in all the stories, select the All Stories option. Then select all the shells one by one in Story 1. If there are no shells in the higher stories of a particular shell, it will not select anything in that area of the higher story. In this way, by selecting the maximum shells in any story, that is 9 in Story 1, you are making sure that all the shells from all the stories are selected. After all the shells are selected, go to the Assign menu, choose Shell Loads, click on Uniform. Set the load pattern name to Dead. Enter the uniform load value of 2 kN per meter square. Then click on Apply. The dead load of 2 kN per meter square has been applied on all the slabs of the building. Click on OK to exit. Now you will apply the live loads, which are different for different set of stories. So, select Similar Stories, and select the slabs again. This time, only the slabs of the stories similar to Story 1, that is stories 1 to 8, are selected. You can verify that 72 shells are selected. 9 shells in each floor multiplied by 8 floors, gives 72. Hence your selection is correct. Go to Assign, Shell Loads, and click on Uniform. Change the load pattern name to Live. And change the value of the live load to 5. Click on Apply, and then click on OK. The live load has been applied on stories 1 to 8. Now, go to any of the stories from 9 to 14. Choose Similar Stories, and select the shells. Then go to the Assign menu, choose Shell Loads, and click on Uniform. Change the live load value to 4.5, and click on Apply. The live load of 4.5 kN per meter square has been applied to the slabs of stories 9 to 14. Click on OK to exit. Similarly, go to any of the stories from 15 to 19. Choose the shells using the Similar Stories option. Verify the count, and assign a live load of 4 kN per meter square, from the Shell Loads option of the Assign menu. Once you are done, go to a story in the last set, that is story 20 to 23. Select the shells, and assign a live load of 3.5 kN per meter square, in a similar manner. The dead loads and the live loads have been applied to all the stories of the building. You will now apply the cladding loads, as you are going to use auto draw cladding. Go to Story 1, using the arrow keys. Although the cladding load is same, the external beams are different for different sets of stories, so you cannot select the All Stories option. Choose the Similar Stories option, and carefully select the exterior beams. All the exterior beams, from stories 1 to 8, will be selected. Go to the Assign menu, choose Frame Loads, and click on Distributed. Enter the uniform load value of 0.2 kN per meter, and click on Apply. Click on OK to exit. The cladding loads have been applied to the exterior beams of story 1 to 8. Next, go to one of the stories from 9 to 14. If the Stories option is not displayed, go to the Display menu, and select Undeformed Shape. Select the Similar Stories option now, and select the exterior beams. Once the selection is done, assign the uniform load of 0.2 kN per meter, from the Frame Loads option, using the same procedure as before. Similarly, go to the next set of stories, that is from story 15 to 19. Select the external beams. Verify the count. And assign the frame load of 0.2 kN per meter. Next, go to the last set, and repeat the process of selecting the external beams, and assigning the loads. Once you are done, you will need to remove the cladding loads from the beams of the topmost story, as there are no walls above them. Go to the last story, that is story 23. The stories option might not be displayed, so go to the display menu, and select Undeformed Shape. Select the one-story option, then select the external beams of the 23rd story. It should show 6 frames selected, as there are only 6 beams in the top floor. Go to Assign, Frame Loads, and select Distributed. Choose the option Delete Existing Loads, and click on Apply. The cladding loads have been removed from the topmost story. Click on OK to exit. Now go to the base, select the base joints using the one-story option. And change them to fixed, from the restraints options of the Assign menu. Go to the Draw menu, and select Auto Draw Cladding. Select the Use Floors option, and click on OK. The claddings have been drawn around each floor of the building. In the next part, you will learn to apply the wind loads. Thanks for watching. Welcome to the fifth part of the video on the final project in analysis and design of a tall building. You have applied the dead and live loads on the building model. Now you will learn to apply one final set of loads, that is, the wind loads to the external claddings. You can notice that the building section is not uniform throughout the height of the building. Thus the windward-facing shells will be in more than one elevation section. If we consider that the wind is blowing from the left side, then it will directly hit some claddings of the section A, and some claddings of section B, depending on the story. So you have to carefully select the claddings section-wise, with respect to each side of the building. You will understand more clearly, as we proceed with the steps. First, define the wind load. Go to the Define menu, and select Load Patterns. Type the load name as wind. Select the load type as wind. And in the Auto Lateral Load option, select the IS code for wind loads, that is IS 875. Then click on Add New Load, and the new load will be added in the list. Select the newly added wind load, and click on Modify Lateral Load. Here, for the wind load settings, we have to refer to the IS 875, Part 3. Open the IS code, and scroll down to the map, for wind speeds. Considering the building to be built in Bangalore, the corresponding wind speed comes to be 33 meters per second. Enter the wind speed value of 33 meters per second in the software. For the terrain category, refer to the clause 5.3.2.1. The terrain of Bangalore falls under category 3. So select the terrain category as 3 in Etabs. For the structure class, the height of the building is more than 50 meters, so select the structure class as C. As discussed earlier, take the risk coefficient value as 1, considering the mean design life of the building as 50 years. For Bangalore, the upward wind slope will be less than 3 degrees. So take the topography factor, K3 is 1. Click on OK, to store the settings of the wind load. Click on OK to exit the Load Patterns dialog box. You will now be assigning the wind loads onto the building claddings. With the Plan View tab selected, click on the Elevation option. Select the elevation side A, and click on OK. Select the All Stories option. And select all the cladding shells. To identify the wind pressure coefficients, open the IS code again, and scroll down to Table 4. The height of the building is 23 times 3, which comes to 69 meters. The width and length of the building are both 18 meters. Thus the height by width ratio is 69 by 18, which comes to 3.83. As the value is between 1.5 and 6, go to the particular subcategory of height by width ratio. The length and width are both 18 meters, so length by width ratio is 1. Hence go to the subcategory of length by width ratio between 1 and 3 by 2. Check for the wind pressure coefficients under this category. The coefficients are plus 0.8, minus 0.25, minus 0.8, and minus 0.8. For sides A, B, C and D respectively, as per the building plan on the IS code. Now, in the software, the shells are already selected. So go to Assign, Shell Loads, and click on Wind Pressure Coefficient. Change the coefficient value to plus 0.8, and select the Windward option. Then click on Apply. The wind load has been applied to the section A. Click on OK to exit. As visible from the 3D model, the side A of the building plan in the IS code also corresponds to some shells of the section B, in the higher stories. Select the elevation option, and select the section B. Click on OK. The remaining claddings in the windward side of the building, which will be subject to the wind loads, are visible. Using the All Stories option, select all the shells. Apply the same wind pressure coefficient, of plus 0.8 in the windward direction, to these shells. Once wind load is applied, go to the Plan View option, and select Story 1. And click on OK. Now the opposite side of the windward direction, that is the side B from the IS code, corresponds to sections C and D, for different stories. First go to the elevation view, select section D, and click on OK. Select all the shells, with the All Stories option. The corresponding wind pressure coefficient for this side is minus 0.25. Select the wind pressure coefficient option from Shell Loads under the Assign menu. Enter the coefficient value of minus 0.25, and select the leeward or sides direction option. Click on Apply, and click on OK. The wind load is applied, in the section D. Go to the Elevation View option, and select section C. The wind load in this section will also be minus 0.25. So select the visible shells, and apply the wind pressure coefficient of minus 0.25, in a similar manner. The wind loads on sides A and B, as per the IS code has been applied. Now you will apply the wind loads on the other two sides, which have the same wind pressure coefficient of minus 0.8. In the elevation option, select section 1, and click on OK. Select all the shells, using the All Stories option. Since the coefficients are same in the other sections also, you can select them together, using the up and down arrow keys. Navigate to the elevation sections 2, 3, and 4, and select all shells in each section. Once all the shells are selected, go to the Assign menu, select Shell Loads, and click on Wind Pressure Coefficients. Here change the coefficient value to -0.8, select the leeward or sides, and click on Apply. The wind load in the elevation sections 1, 2, 3, and 4 have been applied. The software will automatically understand the exterior surface of the shells in each section, and thus apply the direction accordingly. You can check the loads from the plan view. Click on OK to exit. Go to the Plan View option. Select Story 1 and click on OK. The loads are applied in all the shells, in each side. Go to any story from the second set of similar stories. For instance, go to Story 10 by selecting Plan View and choosing the story. You can see that the loads are applied to the exterior shells, even if they are in an interior grid section, and the directions are also correctly set. In this way, you can verify the wind loads and directions in the other sets of similar stories as well. In the next part, you will learn to run analysis and design on this building model. Thanks for watching. Welcome to the sixth part of the video on the final project in analysis. All the properties, sections, and loads have been applied to the building model. Now, you will learn to run analysis and design on it. Select the 3D View tab and select the Use Extruded View for Frame Objects option from the toolbar. The frame extruded view of the building is shown. Go to the Analyze menu and select Run Analysis. Save the file if you have not saved it before. As the number of stories is more, the software will take some time to run analysis on it. Wait for some time for the analysis to complete. You can check the progress of the analysis from the bottom bar. Once the analysis is complete, you can check for the displacement values. The other analysis results, like the forces and stresses, can be viewed by selecting the suitable options from the display menu, as shown in the earlier videos. After analysis, you will run design on the building. In the Design menu, select Concrete Frame Design, and click on Start Design/Check. Wait for some time as the software runs design on the building. Once design is complete, you will get a notification that analysis and design sections differ for a particular number of frames. This means that, initially, the software uses the smallest concrete frames from the auto-select list, which is the 500 by 500 section for columns, and 500 by 300 for beams. In this case, out of all these frame members, 705 numbers of frames have failed the design check, and thus the software asks your permission to reiterate analysis and design. In reiteration, The 705 failed members will be changed to the next higher section, that is, 550 by 550 mm for columns, and 550 by 350 for beams. Click on Yes, and the software will increase the dimensions of the failed frame section, from the auto-select list, and will automatically run analysis and design again. This time, after the completion of running design, there is no notification regarding failure of any members, and the 3D view displays the longitudinal reinforcement. You can check by going to Design, Concrete Frame Design, and selecting Verify All Members Passed. A notification will appear that all concrete frames pass the design check. If any notification appears saying that some elements are still failing, you will repeat the process of reiteration, so that the sections are changed to the next higher section, and so on. Now, there are no failed members in the building. The building now has beams and columns of different sections, from the auto-select list. In this way, you can take care of passing all members of the building, without individually selecting the failed members, defining a new section, and assigning the new section each time. Thus the design of the building is complete. You can zoom into the 3D model, and check reinforcement values in each member. Right-click on any member, to check the design information, and to see which section it is. Go to the Detailing menu, and click on Run Detailing. All the detailing diagrams are generated, which you can see from the left pane, as illustrated in the previous videos. The project report and summary report is also generated, which you can access from the left menu as shown. Thus, you have successfully analyzed and designed the tall building using the Etab software, and also generated its project report, along with the detailing diagrams. Congratulations, you have now successfully completed the project-based course on tall building design. Now, make a video of your project, and submit the next assignment to collect your certificate.